Hi, everyone. Hope you're doing well. Today, we're going to continue our discussion of quantum mechanics, and we're going to continue to focus on bound particle systems. These are systems that sort of approximate atoms, where the particle, maybe an electron, is trapped in a potential. Maybe it's bound to an atom. All of these systems exhibit some common features. For example, they all have quantized energy levels. All right, there are three systems we're going to investigate: the infinite well, which we've already talked about, the finite well, and the harmonic oscillator potential. They're all kind of fascinating, really, but today's focus is on the finite well. All right, hang on, and we're going to switch to the notepad. Okay, as we just said, today we're going to focus on the finite well, this problem, okay? And that corresponds to this potential here. So you can see the difference between the finite well and the problem that we talked about last time, the infinite well. It's simply that the barriers have a finite height, U0, okay? And what that's going to turn out to mean is that in the finite well, the particles won't be strictly confined to the well. They'll be able to kind of leak out into the barrier regions a little bit. And that's really interesting. But it's a little harder to describe. So you'll see this problem is more complicated than the infinite well problem that we talked about last time. Okay? Here, hang on for a minute. Okay, to illustrate what we're talking about, we can just sketch what we expect the wave functions to look like in these two different systems, in the finite well compared to the infinite well. Okay? So just give me a second here to set up what I want to draw. Good, thank you for your patience. Always one that doesn't work, right? Just give me one more second. Oh my gosh. Try once more. And then you'll just have to be satisfied with whatever we get. There we are. Okay. So we know that for the infinite well, that the particle is always strictly confined to the potential well. So if we draw the first three wave functions, they look like this. Notice how they go strictly to 0 at the boundaries, okay? And of course, they're quite familiar to us by now. In the infinite well, we expect things to look somewhat different. The basic idea is that when the particle is inside of the well, it acts like a free particle with positive kinetic energy and should be described by an oscillating function. But when it's outside of the well, it's in a situation where the potential energy, U naught, is greater than the energy of the particle. And so in that situation, we expect the wave function to be a decaying exponential. And so here's what we might expect, that the wave functions look a lot like the infinite well, but with one key difference. And the key difference is that now they're going to penetrate into the barrier region. Something like that. At least that's what we expect. All right? And this is really interesting because it means that there's a finite probability, for example, of finding the electron or the particle in the barrier region, even though the energy of the electron is too low for it to escape the well. All right? Let's look at this more closely, and we'll see if we can get a quantitative description. All right?